Hello everyone, I'm Alfian and today we are going to solve the Leetcode challenge on the number 26 called the remove duplicates from sort array. And for this particular challenge, it describes given an integer array of nums sorted in non-decreasing order and remove the duplicates in place. So we are going to sort it in place and mutating the original array such that each unique element appear only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contains the unique element in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size of nums, and then return the k. So in short, if I have to summarize this, it's about returning how many unique numbers in the array after we mutate the original array of nums right here that passed in as a parameter. Since we are using a TypeScript, then the type is being explicitly declared right here as the array of numbers, and the returning function from the remove duplicates is in a form of number or integer. So let's declare this by using the placeholder of 0, and this is the custom judge. The judge will test our solution with the following code like this. I still don't understand what this means. If you have any idea, you can write in the comment section. And if all assertions pass, then your solution will be accepted. And this is the example 1. The example 1 says that we have 1, 1 and 2, and the output should be 2, which is the k of the length of the mutated array that only has the unique elements inside the array. And the explanation says our function should return k equals 2, which is the nums.length in short, with the first two elements of nums being 1 and 2 respectively. It does not matter what you leave beyond the return k, hence they are underscores. So it's only returning the k number or the length of the array, and the rest of the array after we mutate it will not be recognized by the function right here. And so without further ado, let's solve the code. And the hint says in number 1 is problem, the key is to focus on the input array being sorted. Yeah. And then the hint number 2, it says we need to modify the array in place, and the size of the final array will potentially be smaller than the size of the input array, of course. So we ought to use a two-pointer approach here. So this is the best approach that I can think of, and one that will keep the track of the current element, of course, in the original array, and another one for just the unique elements. So we can declare our unique element of the first iteration of the pointer 1, called the current, equals to the nums, the first element of the array. We can directly declare as the 0, the first element of the nums array. And for the edge case, to check if the nums or the array doesn't contain any elements inside it, then we can add a check. If the nums length is equals to 0, if it is, then we can return 0 right away. If it's not, then we declare the current as the first element of the nums array right here. So I draw something on the excalidraw of the case number 2 right here. And then for the case right here, case number 2, we need 2 pointers like the hint number 2 mentioned, and the first pointer called the reference. And so for the reference is the current array that we declare right here as the first element of inside the array. And for the second pointer called the comparator, and these pointers acts by iterating the array. But for the first iteration, we already declared the current element, as the reference for this first pointer, and for the pointer number 2, which is the comparator, is to compare this element against the reference right here. Compare the 0 and the 0. If they are the same, then the second element or the current iteration of the comparator pointer here will be eliminated because it's non-unique. And we can add a check if for the next iteration, if the reference is the same as the comparator, since 0 and 1 is not the same, then the 1 will be leave it as is. And so we are moving the reference to 1. We get the reference as 1, and then we move the comparator to compare. And then for the next iteration, for the second iteration, if the reference is 1, and then compare with the 1 right here, and then the element inside the comparator pointer right here will be eliminated, and then we are going to be returned like this. And so it will be, for the next iteration, it will be compared again, since both are the same, 1 and 1, and then we are going to eliminate 1 again, and the reference will not move until it finds the unique elements from the comparator pointer right here. And so since 2 is different from 1, and then we move to the next iteration like this. So let me declare this for more verbose approach. Let me describe this by using the current with the blue color. The current, we already declared the current as the first element, which is nums 0 as the first element that we pointed as the reference right here, and the num 0 is 0. And for the comparator or the index that we are currently as the comparator, we can name it, we can color this as color using the green color. Comparator right here is the index. It's the index, and then the index is equals to 1, since comparator starts from the index number 1. And then as we compare by using an if check, let me write the if check right here. Set an if check if the current is equals to the comparator, then we can declare a splice function, I think, using the splice, because splice function is mutating the original array. And then we can declare nums splice. For the first index, for the first parameter is the number of the index that we want to mutate, which is the current index of the comparator, and since the comparator is 1, then we are going to mutate it right here. Locate the splicing parameter right here. And for the second parameter of this splice, which is how many elements that we are going to replace from this splice, and then since we are going to delete 1 element from that index, then we can use 1, because it only takes 1. That is the function of this splice, only takes 1 element of the existing array, and that way we are going to remove the 0 from the index 1. Okay, so let me visualize this using the GSplice. if you look over the MDN docs, the splice says a method of the array instances that mutating element in place, like the one it describes from the Leetcode challenge. And for the splice, let's run this. For the first parameter, it says take index 1, index number 1, which is the March, and then since the second parameter is 0, then we are not going to replace anything, and then 1 is right here. And then for the third parameter, and to fourth and fifth and so on, it's going to be the element that we want to insert. And this place right here, since it's 0, then it will take the place to the index number 1, and the index number 1 will be filled with February. Since it's 0 for the second parameter, then the March will be shifted to the right, and then February takes the place of the index number 1. Let's see if we change the second parameter as 1, then we are going to ultimately removing the March with the February. So let's run this, and as you can see, it's January and February and then April, and then it's the splice. For the first parameter, we pointed to the index number 1, which is right here, and takes one element and replace it with the element that we declare on the third parameter right here. And then February is replacing March. What if we declare another parameter after the third parameter, which is March, and then replacing two elements from the index number 1, which is March and April? So let's run again, and then March and April, they both being replaced by February and March respectively. It's because we take the index number 1, and then we replace two elements inside the index from the set index number 1, and the element that we are going to replace with these elements from the third and fourth parameter of the splice function. Okay, I hope you understand this part. So let's go back to our Xcode drawing. And since 1 is already being triggered, if the current of the reference pointer is equals to the comparator pointer right here, if it is, then we are going to remove the 0 from the array, and then we are moving to the next one. And since we are using the splice, then we are going to iterate all over again. Let me remind you that we are not going to move the pointer since we already used the splice, and we are comparing it again since the reference has not being found unique elements after the reference, which is the comparator. And this one we are using the while loop instead of for loop because it's going to take some time, and the for loop is the comparison between the for loop and the while loop is the for loop only takes the certain amount of elements and cannot be in, and it's not considered dynamic, and it's only a static number because since we are mutating the original array right here, then we should use the while loop instead the for loop. And we can, since it's already iterating for the first iteration, we completed the first iteration, and then we move to the next iteration, which is the iteration number 2, and we can add a check if the 0 is if the current pointer or the reference is equals the comparator pointer right here. If it's not, since 0 and 1 is different, then we can add an else check to address the current right here. We address the current as the new one, which is 1, and current will be 1. by using the else clause right here. Since we are already declaring the let variable right here of the current, then we can simply pass in the current equals to 1. This not current equals to 1, but its current equals the current index that we declare as the comparator pointer right here. And then since it's already declared as the current equals to nums of the index of I that takes the place of the comparator right here, then we are going to move it right here, and then moving our comparator pointer right here by using the I++, and then we can add another check for the next iteration. If the reference is equals to the comparator right here, it is equal, then we are going to splice it again, the comparator, which is the I. Let me simply use this I comparator, or the I. It's still the same thing. The current is equals to the current index of the current from the against the current variable. If it is, then we are going to splice the number of index or the comparator right here, and the number of the comparator right here is currently on the iteration number 2, or the I equals to 2. I forgot to change this to 2 after the I plus product right here, and it takes the index number 2 and replaces one character. Since we are not passing the third or fourth parameter, then we are going to simply move this or erase this, and then we are going to iterate again. And let me remind you that we are not on the else clause because the current is still 1, and we are not moving anything. The only thing that moves is the array after the in place operation right here using the splice function. And so for the next iteration, of course, 1 or the current value right here is equals to I. It is equals, then it triggers the splice function again. It is the same thing, still the same thing. Then we are going to move to the next iteration and to check if 1 is equals to. It is not, then we are entering the else clause right here called the current equals to nums of the current index, the current change to index to the value of the element of the nums array. After this, then for the next one is I++, which is equals to the I equals to 3, and so the comparator moves and the reference moves right here. It's because the current is pointing to the number 2, and then we are doing the same thing again. Let me fast forward this. And we are finally end up on the edge of the array. Then the current will be stays like this, and the iteration stops because the while loop already stopped right here, and we are returning the value right here, returning the array, the mutated array from this splice right here. So we are going to wrap this if and else inside the while loop, and while loop to check if the I is still below the length of the array, which is 5 right here, and then it stops. It doesn't iterate anything to 5 because the while loop checks if the while loop stays while I below the nums length. Since we are already mutating the length of 5, then after we move the comparator to the 5, and the current is equals to 4 right here, and then the I5 is out of bound, and the reference is pointing to the 4, and then the while loop is stopped because the I is already equals to the length of the nums array right here. Okay, so let's go back to our implementation. We can add a while loop while the I below the nums length. Then don't forget to declare the I in order to make the while loop moves and the 2-pointer moves. And then we can add a check if the current is equals to nums the current index. If it is, then we can nums.splice the I the 1. Yep, it is. The index number takes one element, and add a check clause, add an else clause. If it's not, then we are assigning the current value as the nums I of the current iteration of the nums, assigning new value to the current, and then move the second pointer of the comparator, adding it by 1. And then to return this, we are going to return the nums length. So let's run this to see if it works. It's accepted. Let's submit the code by using the Control Enter. Okay, so it's not the runtime, the processing speed is not that best, but it's doable, and also it takes the some memory. Okay, so that sums up. That's about it. I hope you understand this explanation from my video. If you still don't understand, you can ask in the comment section, and also if you have any better solutions, you can also tell us in the comment section. I hope you have a great day, and I will see you in the next video. Goodbye.